All right, in this example, we're solving a radical equation with radicals on both sides of the equal sign. And we'll have to approach this a little bit differently than the simpler problems that we did earlier in the chapter. What you're going to do here is square both sides, and that part's the same in that we were always trying to undo the square root so we could solve. So we'd raise both sides of the equal sign to the second power. And on the right-hand side of the equal sign, what this kind of worked to knock out that square root. So that remains the same. That part remains the same. Over here on the left side, the process will be a little different in that it's very similar to multiplying binomials or using that FOIL method. And when you multiply the square root of x plus 2 plus 1 times itself, you get something that looks like this. Okay, so what you're going to do now is simply FOIL it. So you're going to multiply this radical times this radical, and that has the same effect as squaring it. So in this case, this will leave us with x plus 2. Now then we're going to multiply the first term times the last term here. So multiplying the square root of x plus 2 times 1, which is going to just leave us with the square root of x plus 2. And you're really just doing that again when you're multiplying the inside term. So we're multiplying 1 times the square root of x plus 2. So we'll put another square root of x plus 2 there. And then finally, we're multiplying 1 times 1. So we'll put a 1 there. And all of that equals 3 minus x. We're going to start to combine like terms and move things around a little bit here. So we'll bring down the x, this x, and then we'll take 2 and add it to 1, this 1 over here. So that gives us 3, x plus 3, plus, we'll take the square root of x plus 2 and the square root of x plus 2 and combine it and talk about it now as 2 times the square root of x plus 2. And it's done similarly to the way you would combine x plus x and call it 2x. And finally, we'll bring down this 3 minus x. After we combine our like terms, then we're going to isolate the radical. So we'll subtract 3 from both sides of the equal sign, and we'll also subtract x. And these will cancel, leaving us with 2 times the square root of x plus 2 equals negative 2x, where this cancels out, and then negative x minus negative x, or negative x minus x gives us negative 2x. We still want to isolate the radical, so we'll divide both sides of the equation by 2. And that leaves us with the square root of x plus 2 equal to negative x. We're going to square both sides of the equation again because we do want to eliminate this radical, and that's the only thing that's going to do that at this point. So we'll square that. And just like whereas before, if we square x plus 2, we'll be left with x plus 2, no radical sign, and negative x squared is x squared. What we have right now is actually a quadratic equation. We can move x and 2 to the other side of the equation and then factor it to solve. So that's what we'll do. Subtract x here, subtract 2 here, and now we have an equation of x squared minus x minus 2. So I'll write that down here, x squared minus x minus 2, and I'll set that equal to 0. All right, and we're going to factor this. So if you think about your factors of -2, we're looking for factors of -2 that add up to -1. There's only 2 and 1 that are factors of 2. And if we want to get a -2, one of them will be negative. In this case, it'll be the 2. And that helps describe what the binomials will be. So x squared minus x minus 2 factors into the quantity x minus 2 and the quantity x plus 1 equals 0. If we set each binomial equal to 0 and solve for x, we'll get solutions of x equals 2 and x equals -1. Now, to check these solutions, we would actually take 2 and -1 and substitute them into the original equation, and in order to prove that they are the solutions. And you can certainly do that to identify if they both are, and in this case, they in fact both are.